Now, let's talk about something bigger. What if you have a service that owns its threads, like a logging service that writes messages asynchronously? This looks clean. A background thread takes messages from a queue and writes them. Multiple producers call log method to add messages. But how do we shut it down? If we just interrupt the logger thread, what happens to the messages still in the queue? They are lost. And worse, the producers blocked on a full queue will stay blocked forever. We need a real shutdown policy. So here we have an improved log service with reservations counter. We have a thread sep queue that blocks producers if it is full and blocks consumers if it is empty. We have created a dedicated consumer thread, a logger thread instance that will continuously take messages from the queue and print them. Here we have a flag to indicate whether the logging service is shutting down. It prevents new messages from being accepted once shutdown begins. Then we have a reservations counter. This tracks how many messages have been reserved, that is, promised to be logged, and it is incremented when a producer adds a message, and it gets decremented when the consumer finishes logging it. This ensures shutdown waits until all pending messages are processed. Then the start method. It starts the logger thread. Without calling this, the consumer won't run and messages will pile up in the queue. Now let's go to the logger thread, but before that, let's check this log method. So this method is called by producers to add a message. Inside synchronized block, it checks if shutdown has started, and if yes, it throws an exception, which means no new logs allowed. Otherwise, it increments the reservations, a promise that one more message must be processed. Queue.put message adds a message to the queue and it blocks if necessary until space is available. Let's take a look at logger thread. This is the entry point for the thread's work when we call start method. It locks on the outer log service instance. That's why it's log service.this to safely check the shared states. If service is shutting down and there are no pending reservations, the loop exits. This ensures the thread only stops once all queued messages are processed. If shutdown conditions are not met, then it attempts to take message from the blocking queue. The queue.take method will block if queue is empty, waiting until a producer adds a message. After retrieving a message, it decrements the reservations counter. This is actual logging action in simplified implementation. If thread is interrupted while waiting on queue.take method, it catches this interrupted exception. Instead of exiting immediately, it continues to next loop iteration where it rechecks the shutdown condition. This allows graceful shutdown rather than abrupt termination. And when we end the loop and enters finally block, the finally block is guaranteed to run whether the loop exits normally or due to an exception. This is the right place to close the resources, for example, file handles, network connections, if you extend the logger later. Now let's go back to the stop method. So this, when we call this method, it marks the service as shutting down. The synchronized block ensures thread sep update of this each shutdown flag. Logger thread.interrupt method wakes up the consumer if it is blocked on queue.tick, so it can recheck the shutdown condition once it performs the next iteration. That's why we don't exit this loop immediately. So that's the solution which ensures when shutdown is called, we set the flag and interrupt the consumer. The consumer keeps running until the queue is empty and reservations hit zero. Only then it exits. So all pending messages are written and no producer gets stuck. If you found this video helpful, please give it a thumbs up and subscribe for more technical content.